Hello students, welcome to CBC 2 class, another energetic day. So let's get into the homework discussion, and as you remember yesterday I told you two of the questions we will discuss again, right? So let us quickly go through that two questions and then we'll move on to the further questions. Okay na? So going to the first question, this one, the 17th and 20th questions, some of the students also have messaged in the WhatsApp that, so they are having a doubt in 17th question, and 20th question anyway we have not discussed because of the time deficiency, right now. So coming to the 17th question, the quantity of oxygen required for complete combustion of 1 mole of organic compound, right? 1 mole of organic compound. First of all, you have to understand what is combustion. Combustion is a form of a type of oxidation in which the hydrocarbon, the organic compound or hydrocarbon will be burnt into carbon dioxide and water. During this process of conversion of a hydrocarbon into carbon dioxide and water, there will be evolution of energy also, heat energy also. That is the heat energy which is used in running of machinery, engines, like different mechanical engines, right? So in that combustion, suppose for understanding purpose, you see there is a methane molecule. Let us assume methane is a hydrocarbon, right? So when methane is passed with excess of oxygen gas, excess is passed, but it will be consuming only that much amount which is needed for combustion, burning of 1 mole of methane gas. Understanding, na? So, but you will be sending excess so that complete combustion, 100% reaction will happen. So that converts into, carbon will be converted into carbon dioxide and hydrogen will be converted into water molecule. But how many carbon dioxide molecules and how many water molecules are formed depends upon what is the molecular formula of initial organic compound, right? So I took 1 mole, therefore 1 carbon is there, so which will lead to 1 carbon dioxide molecule only, and in 1 mole 4 hydrogens are there, that each water molecule needs only 2 hydrogens, therefore 2 moles of water molecule will be formed here. So 1 mole of carbon dioxide is formed and 2 moles of water molecule will be formed. Now depending upon what compounds are formed, right, during the combustion, we will come to know how many moles of oxygen gas is consumed during the reaction, right? So here each carbon dioxide molecule is having 2 oxygen atoms. We know every 2 oxygen atoms together is 1 mole. So here 2 oxygen atoms and here also 2 oxygen atoms, right? So 2 oxygen plus 2 oxygen together, it is 4 oxygen atoms. 4 oxygen atoms is nothing but 2 O2 molecules. 2 O2 molecule. That means here it is 2 O2. Understanding the point here, right? So next is coming to this compound, whatever the compound is given. Now he has given here CXHYOZ. CXHYOZ. Now this CXHYOZ. This is the organic compound, but one thing you have to understand is in this organic compound from previously also there are some oxygen atoms. So during the combustion, these oxygen atoms which were there previously in the organic compound, they also will go into some of the formation of some of carbon dioxide and water molecules. So it is not only the oxygen atoms which is initially taken, which will be converted into carbon dioxide and water. Along with these oxygens, the oxygen atoms which are already present in the organic compound will also be converted into, will also be present in some of carbon dioxide and water molecule. There is the logic. You have to catch this point, right now. So if there is no oxygen here, if there is no oxygen, only the organic compound is given as CXHY, just you will do it in the similar manner. But here already oxygen is also there in the organic compound. When such an organic compound is done with a complete combustion by passing excess of oxygen gas, you will be getting carbon dioxide and carbon dioxide and water also you will be getting. But here, how many moles of carbon dioxide you will be getting? X moles, na? X moles of carbon dioxide you will be getting. And how many moles of water molecule you will be getting? Y hydrogen atoms are there, and each water molecule needs 2 hydrogen atoms, right? So Y by 2 moles of water molecule will be formed. Y by 2 moles of water molecule will be formed. Now, understand this point. X moles of carbon dioxide is formed, correct. But I cannot write same like here 1 into 2 oxygen. I cannot write here 2x oxygen. Understand this point, because in these oxygen atoms of entire carbon dioxide, not only the oxygen atoms came from here, but also oxygen atoms came from here or also there. Here also the same problem. Not only the oxygens from here, but also from here are there, right? Understanding. Now what you have to do is total these many carbon dioxide molecules are formed and these many water molecules are formed. So with respect to carbon dioxide, it can be like a 2x oxygen purely from carbon, right? And with respect to water molecules, it will be Y by 2. But there are oxygen atoms which are initially coming from organic compound also. So that oxygen atoms also you have to add. So it is the total number of oxygen atoms are the total number of oxygen atoms are these many, right? 2x plus y by 2 plus z number of oxygen atoms, right? And every 2 oxygen atoms will make 1 molecule. So when you want to find out how many O2 molecules are consumed here, you have to divide this by 2. So that leads to 2x by 2, x plus y by 2 by 2, y by 4 minus z by 2, right? So this you will be getting total number of oxygen atoms. From these oxygen atoms, you have to subtract whatever the oxygen atoms earlier you will be having in the organic compound. This results in giving option C as the answer. Understood this point? This is the total number of oxygen molecules, or 1 second. This is the total number of oxygen atoms, right? So from these oxygen atoms, you will be taking, these are the total oxygen atoms, sorry, that is what the mistake we have done. This is not Z, this is not plus, this is a minus, right? Divided by total number of. So these many oxygen atoms are needed, right, in formation of carbon dioxide and water from outside. Whatever the oxygen atoms are there from carbon and hydrogen water molecule we have taken, and we have subtracted whatever the oxygen atoms are already present in the organic compound. So these are the oxygen atoms which are to be supplied from the outside. That divided by 2 will give you your option C. Hope you have understood, right? So this is the question based on stoichiometric ratio of different compounds involved in an organic reaction or combustion reaction, right now? So now let's go to the next question, that is, observe the given figure carefully and select the correct option. Now what is he saying? There is 1 mole, right? 1 mole is Y grams of hydrogen, Z grams of sodium chloride, 18 grams of water, W grams of iron, X grams of oxygen gas, right? So simply directly you can write 1 mole of hydrogen gas will be equal to 2 grams of hydrogen, 2 grams. Y is equal to 2 grams. Then 1 mole is Z grams of sodium chloride. Sodium chloride is what here? Sodium chloride Sodium atomic mass is 23 plus chlorine atomic mass is 35.5. Both together it becomes 58.5, right? So 1 mole will be weighing 58.5 grams, and he is talking about 1 mole only. So Z is equal to 58.5 grams, right? Then W is equal to iron here. So iron is atomic mass is for iron 56, right? 56 grams 1 mole, and 1 mole oxygen gas, 1 mole oxygen gas is 32 grams. So X is equal to 32 grams. So this is what X, Y, Z, W. Very simple. So now you have to match them with the options. W is equal to 56 is the rounded off number. Actual number is, precise number is 55.8 only. But for our calculation, as already I told you in the previous classes, we have made it into round off. So all of these options are correct for W. Then coming to X, 32 grams, right? 32 grams. Where is 32? This one 32, this one is also 32. So A is wrong, C is also wrong. Then coming to Y. Y is equal to 2 grams. So where is Y is equal to 2 grams? Here Y is given as 1 gram. Therefore this is also wrong. So finally this will be the answer. Let us compare Z also. Z is 58.5 grams, perfectly matching. So in this manner, W can be the answer for this, D can be the answer for this question. It is a simple question only, right? But looking complex when we see it. Now let's go to the next discussion. Now going to DPP 14. What is today's homework? In this homework also, many of the questions are, not many, almost all the questions are of numerical questions only, calculation based questions only. The concept is like that, but it will be interesting, right? More the calculations, it will be more interesting, and also you have to practice more. This is one in which most of the students will be lagging behind in calculation part. So there can be a problem later on. Therefore from now onwards, in summer vacation onwards, you have to take all the steps which can improve your ability or your level in maths understanding or calculation based practice, right? So whatever the fundamental concepts are required, that all you have to brush up. Especially for chemistry, if you say the integration will be needed, integration and differentiation will be needed, logarithms will be needed, basic calculations, multiplication, addition, division, subtraction will be needed, right? So these are the basic things in chemistry part. Whatever maths concepts are there, you can revise them so that it will be better for you. So now coming to the first question, 0.125 moles of any gas at STP occupies X liters. What is he saying? 0.125 moles is occupying X liters. What is X? He is asking. We know any gas at STP, any gas at STP, 1 mole will occupy 22.4 liters. Any gas at STP will be occupying, 1 mole will be occupying 22.4 liters. Therefore, you can say like, if 22.4 liters is 1 mole, then what is, how much volume is given? 0.125 liters. Sorry. This is moles is given. Na? Let's take in reverse, right? If 1 mole is 22.4 liters, then 0.125 mole will be how many liters? That you can calculate as cross multiplication. 22.4 into 0.125 divided by 1 liters. So calculate this one, you will be getting the answer, right? Calculate this one, you will be getting the answer. Easy. Now going to option, you can get the moment you calculate this, right? So you at least this one, this part we can do it, right? We can skip it. Next, calculate the number of atoms present in 1 gram helium gas. 1 gram helium gas. First of all, 1 mole helium will be having how much mass? 1 mole helium means what? What is the gram atomic mass of a helium? What is the atomic mass of helium? 4 AMU. Then gram atomic mass of helium is 4 grams. So 1 mole helium gas will be weighing around 4 grams mass. So 1 mole helium weighs 4 grams. Right? Then he is asking, and this 4 grams will be having how many helium atoms? 6 into 10 to the power of 23 helium atoms. Everybody understood, right? So 4 grams, 1 mole means 4 grams, which will be having 6 into 10 to the power of 23 atoms. 6 into 10 to the power of 23 atoms. Then 1 gram will contain how many atoms? 6 into 10 to the power of 23 into 1 cross multiplication divided by 4. So 4 ones, 4 1.5s. So 1.5 into 10 to the power of 23 atoms is the answer. So just check it. Where is it there? 1.5 into 10 to the power of 23 atoms. Right? Understanding? Simple question. Next, third one. What will be the mass of one carbon 12 atom in grams? Only one carbon 12 atom is there, and what is its mass he is asking. Very simple. It is actually, you know, the mass of 1/12th of one carbon 12 atom. That is what 1 AMU, 1/12th atom mass is 1.66 into 10 to the power of minus 24 grams. Then 1 atom mass will be how much he is asking, right? 1.66 into 10 to the power of minus 24 into 1 divided by 1/12. So 1/12, if it goes on upside, it will become 1.66 into 10 to the power of minus 24 into 12. So if you calculate this one, you will be getting mass of 1 carbon atom. Mass of 1 carbon atom. Understanding? Very simple enough. So these are all logical type of questions. You have to understand the Y map. So if you understand the Y map, it will be very easy for you to make the relation between whatever the quantities they have given. Right? So going to the next question, the number of ions of sodium present in 72 grams of sodium carbonate. First of all, I should know what is the molecular formula of sodium carbonate, and it is a summer vacation for you. You can find some time in doing one very beautiful practice which will help you to be strong in inorganic chemistry. What is that? Is whenever you find any compound name like here sodium carbonate, try to write its molecular formula. If every compound molecular formula is known, then it becomes very easy in calculation part, right? And also it is not that infinite number of compounds are there. There are finite number of compounds, fixed number of inorganic compounds, so whose molecular formulas you can remember during this journey of 2 years for JEE and NEET preparation. Understanding? So the number of ions in a sodium present in 72 grams of sodium carbonate. First of all, sodium carbonate is Na2CO3. Sodium carbonate is Na2CO3. So Na2CO3, here you can understand, if I say like 1 mole Na2CO3 contains 2 mole Na plus ions. 2 moles Na plus ions is nothing but 6 into 10 to the power of 23 into 2 ions. Yes or no? 6 into 10 to the power of 23 into 2 ions. Now, or else you can do in another way, what is the mass of Na2CO3? Because he is asking in 72 grams. 1 mole mass is how much? Let us calculate first that one. Sodium is 23, na? 23 into 2, 46. Carbon, 12. And each oxygen, 16. 16 threes are 48, right? So 10, 16, 8, 10. So 106. 106 grams Na2CO3 contain 6 into 10 to the power of 23 into 2 Na plus ions, right? So up to here you understood? Now, if 106 grams is having these many sodium ions, then how much is given? 72 grams will contain how much? Again cross multiplication. So 6 into 10 to the power of 23 into 2 into 72 divided by 106. These many Na plus ions will be there. These many Na plus ions will be there, right? So just to calculate this one, you will be getting the answer. This part I am leaving to you. So after the class, you can just do the basic calculation, multiplication and division, and can get the final answer and tick mark, identify the answer, option, correct option. Next question. What is the mass of 2.8 liters of hydrogen sulfide, H2S, hydrogen sulfide at STP? We know at STP is also a basic question. At STP, 22.4 liters of H2S weighs, how much it weighs? Tell me. 22.4 liters is 1 mole. 22.4 liters at STP is 1 mole. So it will be weighing equal to its gram molecular mass, right? So what is the gram molecular mass of a H2S? H2S, na? Sulfur is 32, each hydrogen is 1, so total to 34 grams. So GMM of hydrogen sulfide is 34 grams. So it weighs 34 grams. 22.4 liters weighs 34 grams. Then 2.8 liters will weigh how much? Again cross multiplication. 34 into 2.8 divided by 22.4 grams. Khatam. Right? So this you have to calculate. You will be getting the final answer. Right? Next, find the number of hydrogen molecules present in 1.12 liters of it at STP, right? Find the number of hydrogen molecules present in 1.12 liters of it at STP. We know in 22.4 liters, there will be 6 into 10 to the power of 23 H2 molecules, right? In 22.4 liters, 22.4 liters means what? 1 mole, na? 1 mole means Avogadro number of molecules. H2 molecules are there. 6 into 10 to the power of 23 H2 molecules are there. Then, in 1.12 liters, how many moles are there? Again cross multiplication. 6 into 10 to the power of 23 into 1.12 divided by 22.4. Right? So, once (20 times), right? Now this will be this gone, so this will become 22 and 2 ones 3. So this becomes 3 into 10 to the power of 22 H2 molecules. H2 molecules, 3 into 10 to the power of 22 H2 molecules. This is the answer. Perfect answer, na? So simple calculation. Therefore, in a fraction of a second we can do it. Next question. So let's change the color. Coming to how many grams of acetone, a nail polish remover, are present in 0.25 moles of it, right? So first of all, just understand what is acetone. Acetone is an organic compound present in a nail polish remover. The main constituent in nail polish remover is acetone and also alcohols, right? So here acetone is the compound CH3 C double bond O CH3. This is the formula structure of the acetone molecule. 3 carbon atoms are there, 12 3s are 36, plus 6 hydrogen atoms are there, and 1 oxygen is there, that is 16. 6 3s are 18, 3 4 5. So 58 grams is the gram molecular mass of acetone, or 58 is the relative molecular mass. 58 AMU is the molecular mass, right? So by now all my students are familiar with these interconversions. Right now, how many grams of acetone in nail polish remover are present in 0.25 moles? 1 mole of acetone weighs how much? 1 mole will weigh how much? Equal to its gram molecular mass, that is 58 grams. 1 mole of acetone weighs 58 grams. Then 0.25 moles will weigh how much? Again cross multiplication, 58 into 0.25 divided by 1. So right, so just to do the calculation, it comes to around 14.5 something, right? Because it is 58, 0.25 is nothing but 1 by 4, and so 1, 4, 2, 14.5. 2 means 20. 20 divided by 4 will come to 5, right? So this is the point here. So hope you have understood. Let's go to the next question. The ratio of weights of O2 and O3, oxygen gas and ozone gas. The ratio of weights of O2 and O3 is 1:1. That means you are given with oxygen gas and also ozone gas, and he is saying that their weight ratio is 1:1. Means how much O2 is weighing, that much only ozone is also weighing. Both are having same weight or same mass. How can you apply this type of question, solve this type of question is whichever is heavier, right? Take the gram molecular mass equal weight. The gram molecular mass of ozone is 16 into 3, right? So 16 3s are 48 grams, and gram molecular mass of oxygen is 32 grams. So take the heavier one. Whatever the mass of ozone is there, that itself consider the mass of both of them, because he is saying 1:1. If ozone is 100 grams, oxygen is also should be 100 grams. Ozone is 1 gram, oxygen also 1 gram. Ozone is 48 grams, I am assuming, then oxygen also will be 48 grams. It will become, because it is 1:1 ratio, right? So weight of O2 to weight of O2 to weight of O3 is 48 grams divided by 48 grams. Yes or no? 48 grams divided by 48 grams. And now because it is a 1:1 ratio. Now what is he asking? This to be converted into mole ratio. 48 grams ozone, 48 grams is 1 mole, whereas O2 48 grams is 1.5 mole. Yes or no? Because oxygen molecular mass is, I should write more legible, right? So ozone 48 grams is 1 mole, whereas O2 48 grams makes 1.5 moles, because 48 divided by 48, mass by molecular mass, so 1. whereas here this is 48 divided by 32 only, right? So this makes it 1.5 mole, right? So now this is the mole ratio 1.5 to 1. 1.5 is to 1 is nothing but you can write it as 3 is to 2 because it is in fractions, decimals. So that is not given here. So you can multiply with 2. 1.5 into 2, 3. 1 into 2, 2. So 3 is to 2 is the correct perfect answer. Understood, right? Now let's go to the next question. Find the mass of sulfuric acid present in 2 moles of it. Mass of sulfuric acid, right? In 2 moles. 1 mole sulfuric acid weighs how much? 1 mole sulfuric acid weighs how much? Can anybody calculate and get the answer? 1 mole sulfuric acid weighs, sulfuric acid, H2SO4, 2 plus 32 plus 16 4 is 64, right? So 98 grams is the gram molecular mass. 1 mole will be weighing 98 grams. Then 2 moles will weigh how much? Cross multiplication. 98 into 2 divided by 1. That is 196. 196 grams. Understanding this point? So now going to the next question. 196 grams, that is option D. Option D. Then going to the next question. In which of the following cases the number of hydrogen atoms is more? Highest number of hydrogen atoms is present in which of these options he is asking, right? So in this one, 2 moles of HCl. 1 mole will have 1 hydrogen, then 2 moles will have 2 hydrogens here. And here each mole will be having 3 moles of hydrogen here. And here 1 mole will have 1 hydrogen, therefore 2 moles will have 2 hydrogens here. Coming to here, 1 mole itself is having 2 moles hydrogen here. So the highest number of hydrogen atoms are present in 1 mole of ammonia. 1 mole of ammonia. Okay, da? Simple question. Then going to the next point, the next question. How many moles are 9 into 10 to the power of 24 atoms? He has given number of atoms. This number of atoms should be converted into number of moles. Number of moles, N is equal to number of atoms, particles, divided by Avogadro number, that is 6 into 10 to the power of 23. So number of atoms are 9 into 10 to the power of 24 divided by 6 into 10 to the power of 23. So this gone 20, sorry, this makes 1 here. 1 will be there and 6 ones, 6 1.5. So this is 1.5 into 10 to the power of 1. That is nothing but 15, right? So this is 15 moles of helium. It is nothing to do with helium or fluorine or chlorine or neon or whatever element it is. But he is directly asking atoms are given and to convert them into number of moles. That's it. So easy question. Going to the next question. The number of atoms of helium in 100 U. U means what? Unified mass, right? So AMU can also be given as AMU or unified mass or Dalton. All are same. 1 AMU is equal to 1 unified mass is equal to 1 Dalton. 1 AMU is equal to 1 U is equal to 1 D, capital D, right? So now number of atoms of helium in 100 AMU of helium, right? Number of atoms is equal to mass by atomic mass is 100 U divided by atomic mass is 4 U. So U gets cancelled, 4 ones, 4 2 5. 20 by 4 5, right? So here 25 will be the number, 100 by 4. So going to the next question, it was an easy question, previous one. Now going to the weight of 6.023 into 10 to the power of 22 molecules of gas is equal to 1.7 grams, right? 6 into 6.023 into 10 to the power of 22 is weighing how much? 1.7 grams. Then 6.023 into 10 to the power of 23, this makes 1 mole, right? So he is asking us to calculate molecular weight. So molecular weight is calculated for 1 mole. Therefore, I am taking 6 into 10 to the power of 23. 6 into 10 to the power of 22, if it is weighing 1.7, 6 into 10 to the power of 23 will be weighing how much? 1.7 into 6.023 into 10 to the power of 23 divided by 6.023 into 10 to the power of 22, right? So this and this gone, this and this gone, 1 will be remaining. So 1.7 into 10 becomes 17. So 17 grams will be the molecular mass. 17 grams is the molecular mass, nothing but he is talking about ammonia gas. Ammonia gas. Understanding this point? So next, 14th question. Calculate the mass of 3 into 10 to the power of 24 molecules of nitrogen gas, N2 molecules, right? Atomic mass of nitrogen is 14 U. But actually, okay, first of all, what I will do is whatever molecules he has given, that he is asking, these many molecules will have how much weight? These many molecules will be weighing how many grams? So first thing is these molecules I will convert into moles. Then from the moles I will get what will be its total mass, right? Number of moles is equal to number of atoms, that is 3.011 into 10 to the power of 24 divided by 6.022 into 10 to the power of 23. So this and this gone, 1 remaining, so once, twice. So this is 10 by 2, that is 5 mole. This is 5 moles, right? Now 1 mole of N2 weighs how much? 1 mole of N2 weighs 14 into 2, 28 grams. Then 5 mole will weigh how much? 5 into 28, 140 grams. Khatam? Yes or no? Easy enough? Next, 15th. The number of water molecules in 1 liter of water is, in 1 liter of water, how many water molecules will be there? This, a little calculation is needed actually here. 1 liter water will be having how many dash molecules of H2O, right? For this, I should know, if I have mass, I can calculate number of molecules, but here volume is given. Maybe you may be thinking, sir, we have the volume calculation, right? 22.4 liters. But remember, understand, that is for a gas. This is not a gas. 1 liter of water, it is a liquid. Water gas or water vapor is not mentioned, na? It is given as water at room temperature. In what state water will exist as? It is liquid. So for liquids, STP 22.4 liters is not applicable. Please students understand this point, that STP at any gas only at STP will be occupying, 1 mole will be occupying 22.4 liters. That is only for gases, not for the liquids or solids, right? Now this 1 liter by somehow I should get it in mass, weight, then I can calculate it, right? But how I can convert this volume into mass is based on density, with the help of density, right? Density is mass by volume, right? Mass by volume. Density of water is 1 gram per cc. Density of water is how much? At room temperature, 1 gram per cc is equal to mass is x grams divided by volume is 1 liter. 1 liter means in cc we are considering, right? So let us assume 1 liter means 1000 ml, na? So that can be 10 to the power of 3 ml. So x is equal to, if you get it on this side, cc means ml, both are same only. I will write it as for your understanding, to eliminate confusion, I will write it as this one, right? So x grams is equal to 1 gram per cc into 10 to the power of 3 cc. cc gets cancelled. X is equal to 10 to the power of 3 grams. X is equal to 10 to the power of 3 grams. That means 1 liter water is 10 to the power of 3 grams or 1 kg, right? Now you can calculate. We know 50, we know 18 grams water has how many moles? 18 grams means what? Gram molecular mass means 1 mole. 1 mole water will be having how many water molecules? Avogadro number of water molecules. Then 1000 grams water will have how much? Cross multiplication. 1000 Na divided by 18. 1000 divided by 18 will come to 55.55. This is standard calculation. That is why everybody will be remembering this one. You also will remember 1000 by 18 will become to 55.55. This option C is the answer here. Right now. So going to the next question. 1 liter oxygen gas at STP will be weighing. We know 22.4 liters will be weighing 32 grams, right? Then 1 liter will weigh how much? 32 divided by 22.4 grams. So just to calculate this one, you will be getting the answer in seconds. Now find the volume of 8 grams of sulfur dioxide at STP. Sulfur dioxide at STP is also a gas, right now? So volume of 8 grams of sulfur dioxide at STP. First of all, what is the gram molecular mass of sulfur dioxide? 32 plus 32, right? 64. 64 grams SO2. 64 grams SO2 will be having how many liters? 22.4 liters. Then 8 grams will be having how many liters? 22.4 into 8 divided by 64. So if you calculate this one, here also you will be getting the answer quickly. Right now, going to next question. I think 22 by 8, 8 3 is 24. So nearer to option B, you should get the answer. Okay, na? Next. The absolute mass of one molecule of a substance is 5.32 into 10 to the power of minus 23 grams. Find the molecular mass and identify the compound. If one molecule is weighing, one molecule is weighing 5.32 into 10 to the power of minus 23 grams, then 6 into 10 to the power of 23 molecules will weigh 5.32 into 10 to the power of minus 23 into 6 into 10 to the power of 23 grams. So first if you calculate this one, 5.32 into 6 into this will be gone, right? So these many grams it is. This is a GMM is this much, then mm will be simply this 5.32 into 6 U, right? Because GMM will be in grams, mm will be in AMU or unified mass, right? So just calculate this one, you will be getting the answer 30 point something. So this option you will be getting. Calculate it, you will be knowing, right? Then going to the next question, how many grams of neon will have the same number of atoms as 4 grams of calcium, right? So first of all, he is asking 4 grams of calcium is given, right? So the same mass of, if neon is given in it, in this, how many moles will be there, right? No. The question is, let us understand the question properly. How many grams of neon will have the same number of atoms, as there are in 4 grams of calcium. In 4 grams of calcium, some particular number of calcium atoms will be there. If same number of calcium, neon atoms are taken, what will be its mass, he is asking, right? So first of all, let us calculate 4 grams of calcium is equal to how many moles. That many moles neon will be weighing how many grams, we have to calculate, right? 4 grams calcium is 4 by 40, that is 4 by 40, that is 0.1 mole calcium. So if 0.1 mole calcium is there, he is saying that the same mass of neon, so same moles of this will be there, right? So 0.1 moles of calcium is present. In 0.1 moles of calcium, how many atoms are present, tell me? In 1 mole, Avogadro number. In 0.1 moles, 0.1 Na calcium atoms. Now this is the point we need, because he is saying in 4 grams of calcium, how many calcium atoms are there? That many neon atoms to be taken. So now I will take that many neon atoms, 0.1 Na neon atoms, right? Now 1 Na neon atoms will be weighing how much? 1 Na means 1 mole neon atoms will be weighing 20 grams, right? If 1 mole will be weighing 20 grams, then 0.1 Na neon atoms will be weighing 2 grams, that's it. Understanding? So this becomes option A, 2 grams, right? Then going to the last question of this DPP, so 14. What quantity of calcium phosphate will contain 12 into 10 to the power of 24 atoms of oxygen, right? So what quantity of calcium phosphate, that means how many moles of calcium phosphate will have these many oxygen atoms, or these many oxygen atoms will be present in how many moles of calcium phosphate. First of all, you have to understand calcium phosphate Ca3 PO4 taken twice, right? This indicates that there are 3 calcium ions plus 2 phosphate ions, right? And in okay, now you see, suppose you are, let us assume that you have taken calcium phosphate 1 mole, In 1 mole calcium phosphate, how many oxygen atoms will be there? Right? 2 into 4, 8 oxygen atoms will be there. Right now, 2 into 4, 8. 8 Na oxygen atoms are present in 1 mole calcium phosphate. In 1 mole in 1 mole calcium phosphate, 8 Na oxygen atoms are present. 8 oxygen atoms are present, right? Then 12 into 10 to the power of 24 oxygen atoms are present in how many moles of calcium phosphate? So again, cross multiplication. So that is 12 into 10 to the power of 24. 12 into 10 to the power of 24 into 1 divided by 8 into 10 to the 8 into Avogadro number na? Avogadro number is 6 into 10 to the power of 23. So now 10 to the power of 23, 10 to the power of 24. So 1 remaining here, and here 6 ones are 6 twos are, 2 ones are 2 fours are. So this is 10 by, from here 10 will be remaining divided by 4, 10 by 4, right? So 10 by 4, that is 4 ones, 4 twos, 5, 20, sorry, 2.5, 2.5. So 2.5, if you calculate, substitute the exact values, you may be getting 2.49, but for saving the time, I have taken rounded off here. That is Avogadro number. I took a 6 only, 6 into 10 to the power of 23. If it is 6.023, maybe we will reach to 2.49. But for calculation, rough calculations are needed because the options are given very far from one another, right? So therefore, you need not have any issue here in solving this one. So with this DPP 14 homework is completed. So for tomorrow, practice DPP 15. Okay, na? So now let's go to the next topic under basics of mole concept, that is oxidation number, right? So whatever 15 minutes time is there, in this we will be discussing the initial part of the basic rules of oxidation number. What is oxidation number, then how to calculate oxidation number in different elements. What is the oxidation? For some of the elements, oxidation number is already fixed. So for what are that rules and all, general rules, that all let us discuss, and then we will be doing this. Is done? Adena? Okay, sorry. ఒక్క నిమిషం. Right. So oxidation number, first of all, let us understand what is oxidation number, right? So different elements, when they participate in the reaction, we know they may form covalent compound, they may form ionic compounds also. But whether they are forming covalent compounds or ionic compounds, there will be electrons redistribution. In case of ionic compounds, it is complete loss and gain of electrons. One atom will completely lose the electron, one atom will completely gain the electron, or more number of electrons also. That is what making the resultant ions formation. Whereas in case of covalent compounds, whatever the two atoms are there forming the bond, both of them will share their electrons. But these electrons which are contributed by both the atoms, they will be moving towards more electronegative atoms. Suppose I consider there is a bond formed between A and B, and I assume that electronegativity of B is greater than A. Then what this B will do, whatever the two electrons were shared now between B and A will be dragged by B. And during this process, if I want to recalculate how is the electrons redistributed in all the atoms, now I will not count the electron with A, because that two bonded electrons went along with B. They went towards a B. Therefore, when this bond is broken, I feel that A lost its electron. That means it is A plus, and B gained its electron. This was the electron of A, which is lost to B. Therefore, it is getting positive charge. And B, not only it is having its own electron, it is gaining one extra electron, which makes it negatively charged, right? Negatively charged. So in this manner, this is a +1 and this is a -1 oxidation number. So in this way, we will be calculating what is the number of electrons right now in the newly formed compound that particular atom has. That charge, whatever it gets according to electronegativities, right, is the oxidation number. So here electronegativity is one concept, we should know it, right? So that will be coming in detail in periodic table concept, right? So for right now, for understanding purpose, I will just understand this much, that more electronegative atom will gain that bonded pair of electrons, less electronegative atom will be losing that electron pair. Understanding? More electronegative atom will take the electrons, will drag the electrons towards itself, right? So that much point you understand, and that all I will tell you how to use it. Now, to keep track of electron shifts in chemical reactions involving in formation of covalent compounds, a more practical method of using oxidation numbers was developed. In this method, it is always assumed that there is a complete transfer of electrons. Assumed. Understand that it is assumed. That means this is the complete transfer of electron. Actually, they were not transferred. Actually, they were not completely gained by B. Still, they are present between B only, but that electron pair is tending towards B. That is the more important point here. If it is ionic compound, completely onto B. B minus and A plus, they will be existing in the solution. But it is a covalent compound, B and A will be still bonded only, but bonded pair of electrons will be tilting, sliding towards B. So that is what one point we have to understand. Assume that there is complete transfer of electrons from a less electronegative atom A to a more electronegative atom B, right? Less electronegative atom A is losing the electron, and more electronegative atom B is gaining the electron. Understand this point. Now, thus oxidation number is the charge on atom. Charge. This is a charge on an atom of an element it has in its ionic form. If at all this covalent compound is broken down, the bonds are broken down in order to form the ions. In the ions, cation, what is the charge? Is itself oxidation number. In the anion formed, what is its charge? That itself is its oxidation number. Understanding? If the covalent compound, if it is existing as an ionic compound, what are their charges? They themselves are the oxidation numbers. Understanding, right? So +1, -1 here. So same thing here. Thus oxidation number is the charge of an atom of an element has in its ionic form or appears to have when all other atoms bonded to an atom are removed as ion. That means I am removing A as A plus. Then what is the charge of B? That is a B minus. Or I will remove B minus. Then what is the charge of A? That is what he is talking about. Now, in the elemental state, that is in a homonuclear molecules, diatomic molecules, what you will be assuming, suppose you say this is one hydrogen atom and this is another, this is another hydrogen atom. One hydrogen atom has donated one electron, another hydrogen atom has donated one electron into bond formation, right? Now, when this bond is broken, who is a more electronegative atom that will take the electrons? Who is more electronegative atom among these two hydrogens? Both are equally electronegative. Same in electronegativity. If same in electronegativity is there, just assume a tug of war. If both the atoms are of equal strength, then to whatever strength atom, first atom, right side atom is pulling, with the same strength left side atom also will be pulling, that on an average the electron pair will be at the center only. So when such a bond is broken, it has to be broken symmetrically only, that both the atoms will be gaining back their own electrons. When they are gaining back, taking back their own electrons, how many electrons they have given, same number of electrons they are taking back. Therefore, there is no loss or no gain of electrons. Therefore, the oxidation number or charge will come to 0 here. Understanding? So here hydrogen's oxidation number is 0 and this hydrogen oxidation number is also 0. That is the reason what you can understand here in the elemental state or in a homonuclear diatomic molecules, oxidation number, the above written is what? Oxidation number 2H2, right? Above hydrogen it is written oxygen 0. That is the oxidation number. So oxygen oxidation number is also 0. But when that is resulted into H2O molecule formation, H2O molecule formation, here in H2O molecule formation, here in a H2O molecule formation, there is oxygen, hydrogen, hydrogen, and let us assume this is the electron of oxygen, this is also the electron of oxygen, and this is the electron of hydrogen, this is the electron of hydrogen. Now, when you are breaking these bonds, these OH bonds, we know oxygen is more electronegative than hydrogen. So when oxygen is more electronegative than hydrogen, I have to break the bond here. Because I should assume that whenever this bond is broken, I should assume that more electronegative atom will take the both the bonded electrons. So both of the electrons are taken by oxygen. But this is the electron, the blue dot is its own electron only, for which it will not gain any charge. But this was the electron of hydrogen, which is now gained by oxygen, so for which it will be getting -1 charge. And here also the same case will happen. From this also it will be gaining -1 charge. Both together oxygen oxidation number will come to -2, and each hydrogen is losing 1 electron. Therefore, both the hydrogen atoms oxidation numbers will come to +1. That is what is written here. Upon hydrogen is written +1. Upon oxygen is written -2. Right? Hydrogen oxidation number is a +1 and oxygen oxidation number is -2 here. Same is the case here also. H2 plus C2, Cl2 here. Right? Na? H2 plus Cl2 giving rise to 2HCl. Right? In this HCl, it is just a typing mistake here. Just that has to be on above hydrogen. It is that I will explain. You see, there is a formation of a HCl. Right? Hydrogen has contributed 1 electron and chlorine has contributed another electron. We have, let us take a red color, right? And chlorine is more electronegative than hydrogen. Therefore, if at all this bond has to be broken, this will be breaking like this, right? Even the hydrogen's oxygen is also gained by chlorine only. Therefore, hydrogen will develop +1 oxidation number. Chlorine, by gaining its electron back, it will not develop any charge. But the electron of hydrogen it is gaining, right? For which it will be getting -1 oxidation number. So hydrogen +1, chlorine -1 oxidation numbers. So that is what here. And the same case, if I take CH4 plus Cl2 giving rise to CCl4 and HCl. HCl already we have discussed here, +1, -1, right? CCl4, let us understand. In CCl4, if I take, in CCl4, we know C, Cl, Cl, Cl and Cl, right? So here, whatever the electron pairs are there, let us assume carbon electrons are white in color, okay na? Carbon electrons are white in color, and chlorine's electrons are blue in color. I hope these are visible, right? Right, in this manner. Now we know electronegativity of chlorine is greater than carbon. This points you will be learning later on. Who is more electronegative, who is less electronegative. Whatever examples we are taking, that you can remember. And now if chlorine is more electronegative, what will happen? This bond will break like this. This bond will break like this. This bond will break like this. This bond also will break like this. That means carbon will lose all its 4 electrons. Carbon will lose all its 4 electrons. So for every electron it is losing, it will develop +1 charge. 4 electrons it is losing, so it will develop +4 charge. So carbon oxidation number in CCl4, carbon tetrachloride, is +4, whereas each chlorine is gaining 1 electron of carbon. So there are 4 chlorine atoms and each chlorine is gaining 1 electron. Therefore each chlorine oxidation number will be -1, right? In the similar manner, if you consider methane molecule, right? In methane molecule is like this. So in this molecule, let me take again different colors. Hydrogen electrons green in color, let us assume. Okay na? So hope you are understanding. For that purpose only I am writing bigger. Okay. So hydrogen electrons are green in color and carbon's electrons are blue in color. Okay na? Now, in this case, when carbon was bonded with chlorine, this was the condition. Chlorine was more electronegative, but here carbon is bonded with hydrogen, where electronegativity of carbon is greater than hydrogen. Understand it? Carbon electronegativity is greater than hydrogen. If carbon is more electronegative, what will happen, children? If carbon is more electronegative, carbon will gain the electron, that bond will be broken like this. Understanding? Interesting enough? So carbon is gaining one electron from each hydrogen. Like that 4 hydrogens are there. So carbon will gain 4 electrons. If carbon is gaining 4 electrons, its oxidation number will become 4 minus. 4 electrons it has gained, -1, -1, -1, -1. Total -4. And 4 hydrogens are there. Each hydrogen is losing 1 electron. So this is a +1. So carbon oxidation number is a -4 and hydrogen oxidation number is a +1. Whereas in a CCl4, carbon oxidation number is a +4, chlorine oxidation number is a -1. Right? In a reverse manner. Carbon is a positive oxidation number. Here carbon is negative oxidation number. So it all depends upon with which atom it is bonded. Right? So hope you have understood this concept. So we will stop it here and we'll discuss the remaining concept tomorrow. Right now? So like other students are messaging their doubts, they are clarifying their doubts, whatever concepts they are having, you can also reach through WhatsApp to send your queries. Okay na? So myself MVK sir, 8142424141. Okay. So you can send any of your doubts, what concepts we are discussing. Not only the concepts, even questions also you can send me. I am there to help you, right? And physics class will start by 10:20 AM. Okay na? So take the short break, refresh yourself and get back quickly on time for physics class, right? So take care, bye.
Good morning to all of you. Let us continue with free body diagram, tension, and later on we will see pulley problem. Normal reaction I have already taught you yesterday. Again, a bit recapping your free body diagram. What is free body diagram? For solving any problem, in the given problem there will be many bodies. Step 1, isolate one body. Step number 2, identify all the forces which are acting on the body. For example, if there is body and it is on earth, undoubtedly weight will be acting. The surface on which you have kept the body, there will be normal reaction. If it is connected with a string or rope or chain, there will be tension acting on the body. So identify all the forces which are acting on the body. Next step, find the resultant of all the forces which are acting on the body. The easiest way is you consider horizontal direction and vertical direction, right? Take resultant of all horizontal forces and take resultant of all vertical forces. Finally, take resultant of all the forces which are acting on the body, equate to m into A. And all these steps you repeat for all the bodies which are present in the given problem, right? I have quoted one or two examples. Let us consider one or two more examples. I am taking, suppose I have ground. On this ground there is a body. On this body a plank is being kept. This is the plank. I am keeping a plank, right? Now, you are taking free body diagram for this block and plank. So, this is block. Its weight is, first I have isolated block. Weight will act downward. Second force, normal reaction is acting here. So, I can show it here. Let us take it as N1. Clear to you? Now, here they are in contact with each other. So, here also normal reaction will be acting. It will be normal to this surface. It will act like this. So, on this body, because dimension of the physical system you have neglected. Even though I am showing you such a big body, but it is just a particle. So, on this particle, a force, this one let us named N2, this N2 will act in this way. This is your N2. Only 3 forces you have to consider for solving the problem. Clear to you? Next, if I take this body, if I have this body, so its weight will act downward, right? And it is in contact with the ground here. So, you have to take normal reaction here. This will be N3. and N2 will act like this at right angle to its surface. Clear to you? Let us consider now next free body diagram, very famous. I am taking now a ladder. I have this vertical wall, this horizontal surface, and there is a ladder. This is a ladder. I want to draw free body diagram for this ladder. Now what will happen? This is fixed, this is fixed. Now first force which will act on the ladder will be the weight of ladder. It is acting downward. This is weight of the ladder acting in vertically downward direction. Now it has tendency, first you take normal reaction here normal reaction acting is N1. Next normal reaction here, this one is N2. Identify all the forces which are acting on the ladder. I am identifying W, force 1, N1, normal reaction of the ground, N2, normal reaction of the wall. Next, you will have to check in the problem whether they are giving you surface is rough, wall is rough or not. Sometimes they may say you either surface or wall, one may be smooth. Then you will not have to consider frictional force. But if surfaces are rough, you will have to consider frictional force. Frictional force is mu times normal reaction and it will oppose relative motion. So this end will have tendency to slide in that direction. So in this direction, force due to friction will act. This will be equal to mu into N1. Later on in friction unit we will see. At this time I am just showing you force due to friction. Clear to you? Now here when this will try to slide in that direction, this end will try to slide in downward direction. Then here frictional force will act in upward direction, force due to friction 2, and this will be equal to mu N2. At this time we are just trying to draw free body diagram. We are trying to identify all the forces which are acting on the ladder. The total how many forces are acting? Weight, normal reactions N1 and N2, and force due to frictions FFR1, FFR2. Total 5 forces are acting. When you will be solving the problem, what you will do, if suppose ladder is in equilibrium, then you will take horizontal forces, just addition of horizontal forces equal to 0, addition of all vertical forces equal to 0, and I will teach you moment of force. You will have to consider condition for rotational equilibrium for solving the problem. Means you have to consider the conditions for translational equilibrium and condition for rotational equilibrium for solving the problem. At this time, we are just trying to know how to draw free body diagram, how to identify all the forces which are acting on the body. Did you understand it clearly? If you understood it, then after free body diagram, let us go for what is tension. Tension, in the beginning I should say you, it is neither a scalar nor vector, it is a tensor quantity. Right? But how to solve the problem? For solving the problem, we will have to consider it to be acting in a particular direction. Actually, any body you take, every body is three-dimensional. You take a rope or a string or chain, all will be three-dimensional. The molecules will be arranged in three dimensions. The molecular forces will be acting in all the directions because molecules are present in all the directions. So, we will simplify. We will consider, okay, any chain or rope as one-dimensional array of molecules. You have seen garland of pearl. If you compare one pearl from one molecule, second pearl from other molecule, in between those two, whatever force is acting, that is molecular force of attraction. That's not tension. Now suppose when you exert forces, you try to increase the separation between any two molecules, then additional force will be developed. In between those two molecules, it will be tension. If you consider any body, tension force will always act away from the direction in which external force is being exerted. I just want to show you, suppose I will have a body here and second body I have connected here and I am exerting force here. This one you take a smooth horizontal surface. You have exerted force here. So, tension on M2 will be acting in this direction away from applied force. On M1, only one force will act and that is tension. It is again away from M1. Due to this tension only, when M2 will move, M1 will also move in the same direction. And because frictionless flow you have taken, guaranteed when you will exert force, M1 and M2 will move. If there is tension, acceleration of M1 and M2 both will be equal. I will show you how to use free body diagram for solving these kind of tension problems. First you tell, did you understand this? If you understood, then some basic problem I am showing you. A basic fundamental problem related to the utility of free body diagram for solving problems related to tension. Suppose I have, a rope. This is IIT asked question. I have a rope of mass M and its total length is L, kept on horizontal frictionless floor. Now, you are exerting force F here in horizontal direction. Since there is no friction, so this rope will move in this direction, let us suppose with acceleration A. We want to find tension at a distance x from the end where force is being exerted. You want to find tension at a distance x from the end where you have exerted the force. First, what you do? Take whole rope as one body. If you take whole rope as one body, then in horizontal direction, because friction is not there. So, for whole rope in horizontal direction, only one force will act, and that force is F. So, net force is F. Simplest problem, but you will be stunned to know it is already in IIT Advanced they had asked this question. Okay, no? And not once, they have repeated it. So, your net force acting on the body is F, and net force is mass into acceleration. This is equation 1. Clear? Now, consider only this part. So, this part has length x. How many forces are acting on this part? Two forces are acting in horizontal direction. This force is F, and here tension will be acting away. So, net force F net, this will be equal to F minus T. This net force will be equal to mass of this part into acceleration. What will be mass of this part? This will be equal to mass per unit length into length. Right now, what will be the mass of x length of the rope? So we are taking linear mass density. Mass per unit length, m by L, into length into x. So this is mass of this part. This into acceleration, equation number 2. Clear to you? Now you take this part. So I am taking now this part. This one will have length L minus x. Now identify how many forces are acting in horizontal direction on this part. On this part, only one force is acting, that is tension. Clear to you? And this tension will be equal to mass per unit length into acceleration, equation number 3. Understanding me now? Yeah? Clear to you? All 3 equations are in front of you. Check you are following or not. This is m by L, L minus x is the mass of L minus x length of the rope. Now, you want to find out tension. Either you use equation number 1 and 2, or you use equation number 1 and 3. Correct? If you are using equations number 1 and 3, 1 gives you A equal to F by M. Substitute this value of A from this equation to equation 3. M by L, L minus x, F by M, M cancel, you are getting 1 minus x by L, F. L you will be dividing here, 1 minus x divided by L, 1 minus x by L into F. This will become tension acting at a distance x in the rope from the end where you have exerted the force. Clear to you now? Check once. Yeah? Slowly you go for free body diagram and tension problem. When you will be coming again, we will teach you in detail. When you will be coming, we will start from the beginning. Many children have asked from me this. And we will not start. Before that, we will teach you mathematical tools. Differential calculus, integral calculus, all we will teach you. So don't bother. At this time, basic concepts I am giving you, try to learn that. It will help you a lot in understanding physics when you will come near to us. Tell me, did you understand now? Have you noted it? In this, they have not asked. I can ask from my side, same problem. Find tension at a distance x from the free end. You have found tension at a distance x from the end where force F has acted. Now I am asking you find tension at a distance x from the free end, from opposite side. Clear to you now? You can find out now. Now, same problem, identical problem I am giving you. Okay, no? If you have noted it slightly, I want some space. So, this side I remove. Okay, no? This much space I need. Yeah. Now, I am giving you same mass m and it is connected with a rope. This is kept on a frictionless floor and you are exerting force F here. It has mass small m, block has mass capital M. Clear to you? And now it has length L. I want to find out how much force is acting on capital M and how much tension is acting in the rope at a distance x from the block. Means I want to take here tension here at a distance x. Clear to you? Slowly learn. Okay, no, very, very important concept you are learning. Plenty of problems you will find based on free body diagram and tension in our material. So, our material is very, very important for you. At this time, I am giving you basic concepts so that you will be capable to solve the problems, and I myself will solve all classwork, homework for you. Okay, no? So, don't bother. Your target is only to learn. Right? So, whole system you take as one body. Block and rope. So, you have mass m and this rope has mass small m. Block plus rope, total mass is capital M plus small m. Frictionless floor, only one force will act and that force is capital F. I am too slow. Learn it. Completely new concept. So, what will happen? F net, this will be equal to m plus m into a. Suppose system is going in this direction with acceleration a. Friction is not there, guaranteed system will move along the direction of force. Equation 1 is ready. Clear? Now, take free body diagram for the block. Very simple. So this is the block. On this block, M, only one force will act. Let us take this force is a small f. System goes like this. A small f will be M into A. From here, A is F by M plus M. Right? Substitute the value. F will become M by M plus M into F. This is the force which is acting on the block. Clear to you? Now, you take this as one system. I mean circling. This as one system. Okay. I draw the diagram also. Here, your block is there. And only this much part I take. It has length x. The mass will be how much? Mass per unit length into x. And here, force acting is only tension. See the figure? Right? Only one force is acting, and that is tension. Okay, no? So, how much tension will be? F net equal to total mass M plus M by Lx into A. Mass into acceleration. Because F net is only tension. If friction will be there, then I will take one more force in opposite direction, acting on the block. But at this time, in Newton's laws of motion, we are not considering friction. Friction will be next chapter. Did you understand this? Now, you take acceleration value from here. You are getting T equal to M plus M by L x, and A is F by M plus M. Is it clear to you? Understanding me? Yeah? This is tension acting at a distance x in the rope from the block. But here, a very nice conclusion we can draw. If I neglect mass of the rope, means I am neglecting a small m in comparison to capital M. Suppose a small m is very, very small. So much small that we are neglecting it in comparison to mass of the block. Then what will happen to the force which is acting on the block? It will become M by M into F. This will be F. Am I right? And here, this part will become 0. This M will be neglected. So, T will be equal to M F by M. Again, it will be F. What conclusion you can draw? If mass of the rope is considered, then tension in the rope will be a function of its distance. At different points of the rope, tension will differ, because then this x term will stay here. But if in comparison to mass of the block, you are neglecting the mass of the rope, which usually we'll do. 99% problems, whatever we will solve, we will not consider mass of the rope, mass of the pulley. We will consider only mass of the block. Most of the problems. So what will happen? Whatever is string or rope or chain you will have, at every point on the rope, every point of the string or every point of chain, tension will be equal. there will be no change in tension. At every point, tension you can take equal. When tension differs, when you consider mass of the rope. Did you understand? From this particular problem, I wanted to show to you that tension will be function of x if mass of the rope is considered. If mass of the rope you don't consider, then at every point on the rope, tension will be same. Clear to you? One or two more examples I want to take before starting your classwork or homework from worksheet. So, let us move to next question. I am taking 3 blocks. Don't think that I am teaching you in too much detail. Basics I am teaching you. Simple problems I am teaching you. Okay, no? So, I have taken 3 blocks. M1, M2 and M3. This is a very big unit beta. I am just showing you how to apply in simple problems concept of free body diagram and tension. So that basics of, basic problems on free body diagram and tension you will be capable to solve. Right? Some trick or technique also I will give you. I have taken 3 blocks, M1, M2 and M3. They are connected with a string. Masses of a string I have neglected. So, M1, M2, M3, and here I am exerting force F. You see how I have exerted. Here, tension you take T1, here take tension T2. Clear now? I am slow now? You are capable to understand now? Yeah? Now, what to do? Total system M1 plus M2 plus M3. You take as one system. Whole India one. Don't divide in states. If you take whole as one system, then only one force is acting if surface is smooth. Always I am telling when surface is smooth, because if you will take rough surface, then frictional force will come into picture and it will oppose the motion of the body. And you will have to consider drag force also. Okay. So first, if I take whole as one system, then net force is F. This will be M1 plus M2 plus M3 into A. Let us suppose system goes in this direction with acceleration A. From here, get the value of A from first equation. A equal to F by M1 plus M2 plus M3. You keep in your hand. Now, I want to find out T1. Concentrate on body of mass M1. On M1, only one force is acting, T1. So, T1 will be equal to mass into acceleration. So, your T1 will be equal to M1 into A, M1 divided by M1 plus M2 plus M3 into F. Clear to you now? Now, concentrate on T2. Now, treat M1 and M2 as one system. If you take M1 and M2 as one system, then only one force will be acting. If you take M2 as isolated system, then two forces will be acting, T2 and T1. But if you take M1 and M2 as one system, then T1 will become internal force. Only T2 will be acting. Then what will happen to T2? T2 will become equal to M1 plus M2 into A. This will become M1 plus M2 divided by M1 plus M2 plus M3 into F. Right. A very nice conclusion you can draw from here. You see here, in these two, denominator is algebraic sum of all the masses. You have added M1, M2 and M3, all three, means total mass, denominator. And for numerator, if you want tension here, opposite to F, you go for the mass. You have taken only M1. You want tension here, the left of this side. You have taken in numerator M1 plus M2. What do you mean by that? Wherever you want to find out tension, take denominator as algebraic sum of all the masses. And numerator as just go opposite to the direction in which force you have exerted. At whatever point you want to find out tension, in left of that, whatever mass is there, you take it as numerator and multiply by F. We want to generalize it. For that, I am giving you n number of blocks, M1, M2, M3, dash dash dash, MP connected with MP plus 1, this is P plus 1, and then dash dash, and then you have Mn, and you are exerting force F. This is a smooth surface. Okay, no? Then at any point you want to find out tension. Suppose we want to find out tension acting between pth body and P plus 1th body. So here we want to find out T. Just now I have taught you. T will be equal to how much? Add M1 plus M2 plus left of this up to P. Don't add P plus 1th mass. Wherever you want to find out tension, before that whatever masses are there, you add and keep in numerator. And denominator, add all the masses, M1 plus M2 plus M3 plus dash 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 plus Mn, and this into F. Understanding me now? So in short form, you can write sigma I 1 to P Mi by sigma I 1 to N Mi into F. Sigma I 1 to N Mi means M1 plus M2 plus M3 plus M4 plus so on up to last body Mn. Sigma I equal to 1 to P Mi means you start M1 plus M2 plus M3, go up to pth body, that into F. Suppose I want tension here, I want T1. Left of this is what? M1. The numerator will be only m1. Denominator is algebraic sum of all the masses into F. I want tension here. Numerator will be m1 plus m2 plus m3 divided by sigma m, sum of all the masses. Denominator is same into F. Are you understanding? In more depth, all these concepts I will be teaching you when you will come near to us. Right? Now, is it clear to you? Understood? If you understood that, okay, no, many things are there which we will talk about this. So many different kind of problems you will be getting. One more small concept I want to give before starting the class work. Suppose same body 1, body 2, body 3. Okay, here you are exerting force F, same concept. There you have talked about tension, here you will speak about force of contact, but concept is same. Now, you want force of contact, you will understand nicely if I name it like this. Go opposite side. This is M1, this is M2, this is M3. Let us take this is T1, this is T2. Go opposite to applied force. So here you want T1. T1 will be how much? In this way, when you are drawing it, means surface is fixed and this is smooth. So here before this M1 by total mass M1 plus M2 plus M3 into F. Here go opposite to F, M1 plus M2 divided by M1 plus M2 plus M3 into F. Understanding me now? Yeah? I will teach you, I told you now, in too much detail when you will come near to us at this time. Just basic fundamentals I am clearing. If you understood this, then let us start the class work. In class work, most or homework, most of the questions will be based on whatever I have taught you now. Okay, no? Or yesterday, whatever I have taught you. We are starting with first problem. Two spheres they have given you. See the figure A and B. And they are placed between two vertical walls as shown in the figure. They are asking you, draw the free body diagram of both the spheres. Concentrate, slowly learn. We are not in a hurry. These basics will help you to solve highly typical problems, to too much difficult problems. If you are master of free body diagram, you will be capable to solve problems related to many chapters. Newton's laws of motion, work, power, energy, friction, so many units. So, I want to draw in this problem free body diagram for A and B. So, this is body A. First, consider body A. This is my body A. I have isolated it. Now, on this, identify free body diagram. Now, so first you have to identify all the forces which are acting on body A. To check, first, they have not told anything. Here, its weight will act WA. Clear now? This is gravitational force. Okay, it is in contact with this surface. So here, normal reaction will act. Let us take this normal reaction is N1. Clear to you now? Two forces you have identified. this is center of mass. I told you that in Newtonian mechanics, in the beginning, we are considering only particle concept. Even though it is a sphere, we are neglecting the volume. So whatever forces you will be exerting, all will be pre-assumed. It is acting on a particle. Total mass is assumed to be concentrated at its center of mass. So two forces you have identified, WA, weight of the sphere A, and one normal reaction of the ground. Now it is also in contact with this. When it is in contact with this, so here other normal reaction will act. This is N2. This is the force exerted by wall at right angle to the wall, away from the wall. And also A is in contact with B. Here one more normal reaction will act. This force you take as N3. Check. Total 4 forces you have identified which is acting on block A. Weight of the sphere, N1 normal reaction of ground, N2 normal reaction of vertical wall, and N3 that is contact force acting between A and B. Normal reaction itself is a contact force. In contact force mainly we are taking two forces, normal reaction and frictional force. In the beginning in Newton's laws of motion, we are not considering frictional force. So in front of you, free body diagram for sphere A is ready. Learn. Now I am concentrating on B. Sphere B, this is small, right? Here in this direction, 1 minute, here this force N3 is acting on this. Okay? Now this N3 on this, you are exerted on this, so here you will be taking N3. On this, N3 is acting in this way, its weight WB is acting in this way, right? B will be exerting force on this in this direction, so you will have to take in this direction. A will be exerting on B in that direction. So I have taken N3 here. And now third force will be the force exerted by this wall on B, because you are taking all forces at center of mass. So N1, N2, N3 you have already taken, you should take N4. So on sphere B, only 3 forces you have taken. WB, N3 and N4. This force, now in this figure I show you, this is N3, here is WA, here you have taken N1, here you have taken N2, here you have taken WB, here you have taken N4, N3, on this you have taken in this direction. Check now, all the forces I am showing you on both the block, both the sphere A and B. In this figure I have shown you at what points it is acting. But when you are solving the problem, because dimension of the system you will be neglecting, you will be considering whole body as one particle, then all the forces you will have to show acting only at one point, and that point will be center of mass. For example, here I have shown you WA, N1, N2, N3. For this, WB, N3, N4. Whatever they will ask you, you will have to take resultant of only these forces. Suppose I want to find out any parameter related to this. If body B is at rest, it means net force acting on sphere B will be 0. So how to find out? I will just resolve it in this direction and in this direction, in horizontal direction and in vertical direction. And then whatever horizontal direction forces are acting, I will equate to 0. And again factor sum of all the forces which are acting in vertical direction, I will take it to be 0. That is condition for translational equilibrium. But at this time, they have simply told draw free body diagram. So we have drawn free body diagram. Clear to you? Point of application is also playing very important role when you are drawing free body diagram. Okay, no? I want to show you now. This concept is also very useful. When problem will come, I will show you. Let us move to next question. The weight of an aeroplane flying in the air is balanced by. Now, aeroplane is in air. How many forces will act? First, undoubtedly, I will take up thrust. But most important thing here, okay, aerodynamic thrust we are taking from Bernoulli's theorem. Okay, no, pressure difference actually depends upon the shape of the wing. P plus half rho Vs squared will be constant. So when aeroplane is moving, its wings are manufactured in such a way, okay, no, that pressure difference will be existing in between upper part, okay, above the wing and below the wing. And this pressure difference will be creating an upthrust. Okay, so here vertical component of the thrust created by air current striking the lower surface. No force due to reaction of gases. In aeroplane, gases are not coming out. In rocket, it is coming out. There we can say that a rocket will be moving based on Newton's third law. Upthrust of the air, which will be equal to the weight of the air having the same value as the plane. It can't be. Weight of aeroplane guaranteed is much more than the weight of air which this one is displacing. It happens in water. Okay, no? In water, if any substance is floating, then upthrust is balancing the total weight of the body. Guaranteed when answers are not A, B and C, then the answer will be D. Force due to the pressure difference between the upper and lower surfaces of the wing created by different air speeds on the surfaces. This topic will be learning in too much detail in fluid dynamics in Bernoulli theorem. It is known as aerodynamic lift. At this time, you may not have knowledge of Bernoulli theorem. Okay, no? This is a direct question related to aerodynamic lift, but here I have to give answer to you. You will be taking answer D. Let us move to next question. When a body is stationary, we'll go for Newton's first law. A body is at rest. How? A body will be at rest means its initial state is that of rest. A body will be at rest when no net force will act on the system. Net force does not mean that no forces are acting. Forces may be acting. But net force means vector sum of all the forces should be equal to 0. Should be a null vector. So here there is no force acting on it. The force acting on it is not in contact with the body. The combination of forces acting on it balances each other. So many answers will be, a body is stationary, there is no force acting on it. That is also one of the answers according to Newton's first law. Third, you contact. Second is not. The force acting on it is not in contact with it. That's also possible. If no force is acting on the body, body will be at rest. But when many answers are there, you will have to see which is most suitable answer. So when a body is stationary, number 3, the combination of forces acting on it balances each other is more appropriate answer. The combination of forces means vector sum of all the forces which are acting on it. Okay, the net force means vector sum of all the forces, and that should be equal to 0 for a body to continue its initial state of rest or uniform motion along a straight line path. Did you understand? Let us move now to next question. Find the acceleration of the blocks. Simple, they are asking you acceleration. You are exerting force F. The whole I will take as one system. They have not spoken about friction. Only one force is acting, and that force is F. So, F will be equal to total mass into acceleration. A will be equal to F by m1 plus m2. Actually, in this question will become too good if they may ask what is the contact force between m1 and m2. You will be capable to solve that. Can you tell me what will be the answer? I have told you, just now I have taught you. What will be contact force acting here? Okay, for this answer is here. But I am creating a new question. If I am asking you contact force, then what will be contact force? Go opposite to applied F, m2 by total mass m1 plus m2 into F. That will be the answer. Clear to you now? Now, let us move to next question. Find the accelerations of the blocks. Again, acceleration they are asking. Acceleration of both the block will be equal because whatever T they show you, this T will become internal force. Right? They should ask actually what will be the value of T. But anyhow, acceleration. So, if I will take this whole as one system, then on this whole system, only one force is acting, and that force is F. This F will be equal to total mass into acceleration. So, F will be equal to m1 plus m2 into A. Your A will be equal to F by m1 plus m2. This will be the answer. You are capable to find out T also. What will be T? This T. This T will be equal to M1 opposite to F. Before T, M1 by total mass. M1 plus M2 into F. Extra. From my side I am telling you a new question. Here to simply they have asked acceleration of the block. Whole total mass you take as one system and you have exerted force F. F will be equal to M1 plus M2 into A. A will be equal to F by M1 plus M2. Check this from here. Let us move now to next question. Draw the free body diagram of the blocks M1 and M2. A good question. So, I am taking first for M1. This is M1. Okay? And here angle they have given you alpha. So, first force you have taken M1G, the weight of the block. Yes, identify how many other forces will act. Now, you will be taking here normal reaction. So, in this direction, normal reaction is acting. Right? Two forces are acting. Here, now, one more force is acting and this is your tension. Clear to you? Now, for solving these type of problems, what you do, mg you resolve. If this angle is alpha, then this angle will be 90 minus alpha, this angle will be alpha, this component will be m1g cos alpha, and this component will be m1g sin alpha. Check. Free body diagram is ready. Right? I have resolved M1G in two parts. Along the inclined plane, M1G sin alpha. At right angle to inclined plane, M1G cos alpha. Now, at right angle to inclined plane, body is in equilibrium. So, your N will be equal to M1J cos alpha. This N will be very useful if they will give you this inclined plane is rough. Means you will have to consider frictional force, then this value of N will be very useful. But here they have not spoken about that. And in Newton's laws of motion, we are not considering. So, even you know N equal to M1G cos alpha, it is of no use for you for solving problems. They are showing you that M1 is moving up with acceleration A. So, here second equation will come T minus M1G sin alpha will be M1 into A. Clear to you? Now, we want to draw free body diagram for M2. The M2, here I show you, this is M2. This angle, they have given you beta. Same way, first force, here string is there, here will be T. So here first you take weight, M2G. Clear to you? And now you are taking here normal reaction. Here you have already taken N. Let us take N dash. This angle is beta, so this angle will be beta. beta, 90 minus beta, beta. This will become m2g cos beta, and this will become m2g sin beta. Is it clear to you? The free body diagram is nothing but identification of all the forces. First, you have on M2, M2G, N dash T, three forces. Later on, for solving the problem, what you have done, M2G you have resolved in two parts, M2G cos beta, M2G sin beta. Now, they are showing you that system is going down with acceleration. Friction is not there, whether N dash will be very, very useful, M2G cos beta. If friction will be there, then you will be considering mu into N dash opposite to the direction of motion, means in upward direction you will have to take frictional force. At this time, surface is smooth, so there is no need of N dash. Here, simply you will take M2G sin beta minus T equal to M2A. Clear? These two equations directly also you can write. If they will ask me acceleration, then I will take net force. A net will be equal to F net by M total. Okay, no? Our F net, this system is moving in this direction. So, this will be equal to M2G sin beta minus M1G sin alpha divided by M1 plus M2. You just add these two, T will be cancelled. You will get M2G sin beta minus M1G sin alpha divided by M1 plus M2. Same answer you are getting. Here, in just one line, I have told you A net. If they will ask you tension, no problem, get A net, and after finding that A in any one equation, either here it will be more easier because T will become M1A plus M1G sin alpha. Substitute the value of A, tension in the string you can find out. But here in the question, basic question they had asked, free body diagram in front of you, this is free body diagram for M1, this is free body diagram for M2. No need of these calculations. Extra I have told you how to find acceleration in of the system and tension in the string. Clear to you? Now, let us move to one more problem we can do. Draw free body diagram of M1 and M2. Again, they have not spoken about friction, so friction we are not considering. If I take M2, so here M2G will act. Here is the string. So here T will act. Free body diagram ready. And friction is not there, guaranteed it will move. And it will move in downward direction. Why not? M1 may be very, very large in comparison to M2. This particular case, I was quoting with one example with elephant and a rat. They are sitting on the top of a hill. Rat started falling and calling his friend, help me. Elephant is holding the hand of falling rat. Can he pull? Elephant has lot of energy, but friction is not there on the upper surface, of the hill. You'll be stunned to know rat whose falling mass is very, very less will pull the elephant down along with himself. Okay, no? So here you will have M2G minus T M2A. Extra I have given you. Free body diagram is already here. And if you take M1, this is M1. On this, only one force is acting T. So, what will be the value of T? T will be equal to M1A. Right? Free body diagram is here. Only one force is acting in horizontal direction. If you want to find out acceleration, nothing you do, add these two equations. If you are adding these two, you will get M2G, T cancelled, M1 plus M2 into A will become M2G by M1 plus M2. Check, A is ready. Once you got A, you can easily find out T. Your T will be equal to, substitute in this M1. M1, the value of A, M2G by M1 plus M2. Easy enough. I'm just showing you how to solve problem by using concept of free body diagram. Whereas in the question, they have simply told you, draw free body diagram. Free body diagram already is here and here. You have already identified how many forces are acting on M1 and M2. Along with that, I have told you how to compute accelerations of M1 and M2 and how to calculate tension in the string. Tell me, did you understand till here? Yes, no? I'll continue from here. Tomorrow, all the problems will be continued on. Okay, no? For today, till here only I am keeping. Lot of problems are there I'll have to solve. Then only a new topic I can start. Okay, no? For time being, I am stopping now. 10-minute break you will have now. After that, your math class will start. Thank you. Have a nice day.
Good morning, students. So yesterday we have discussed about sets and Venn diagram, and I have given you worksheet homework from that. So we'll be discussing today that only. All right. I think there were 12 questions, so I hope all of you have done those questions. Let's check out them one by one, and then today we'll be learning about some operations of sets. Okay. So let's do it. First, the shaded region in the Venn diagram given below represent what? Right? Yesterday this kind of question we have done, correct? The shaded region in the given diagram represent what? So there is C. Oops. If you see here, right, C is already there, right? C part is there, so C will be definitely coming, right? And then this part is also available, right? So this part is which part? A intersection B, right? So what they have done, they have taken A intersection B union C, right? First they have taken A intersection B, so from A intersection B you will get this part, right? This, understood? And then they have taken union with C, then only this whole thing will be coming, right? So that is why the answer for this will be what? A intersection B union C, which is option B, right? Which is option B. Okay. Next, the shaded region in the Venn diagram given below represent what? Right? The shaded region in the Venn diagram given below represent what? So this is only B, right? This is what? Only B. Only B, right? It means that elements which are present in B but not A, right? So this we know, which is that this is B minus A, right? B minus A. If they are saying about A minus B, then A minus B will be like this. This is A, this is B, this is A minus B, right? Then if they are saying A dash minus B, right? A naught minus B, then you need to have a universal set for that, right? Right now we don't have it, so that is why we cannot say this is option C or D. It is option, not even A, it is option B. Okay, it is option B. Okay, I hope this is clear to everyone. Right, this is just a definition. Next, the shaded region in the Venn diagram given below represent, right? This area represent what? So this we already know, that we have seen that A intersection B intersection C, right, is nothing but this area. Right, this is the common area between all the three, A, B and C. That is why we say it is A intersection B intersection C, right? The second one, what they are saying, A union B intersection C, right? A union B intersection C, right? This, for that, you need to have a bracket, right? You need to have a bracket either on this side or this side, correct? We can't just make it directly, right? And A union B union C is the entire thing, and that will be the entire thing. So this is not there also again, right? That is why this C is also not the correct answer, right? Okay, the next, fourth, three sets A, B and C represented by three circles in the given diagram. What does the shaded region represent, right? What does the shaded region represent? So if you see here, right, this particular part, right, this particular part represent what? A intersection B, right? This thing represent A intersection B, and this part, right, this part represent what? A intersection C, right? This part represent what? A intersection C. And then what we have done, we have taken union of it, right? What we have done, you have taken union of this, right? So if I see, if I take it common, right, this will be A intersection is common in them, so you can write A intersection B union C, right? A intersection B union C, right? So that will be the answer for this one. So what will be the answer? The answer will be option D here, right? The answer will be option D. Okay, I hope this is clear to everyone, that what the answer for this is why A intersection, actually it is what? A intersection B union A intersection C, but then what have we done? We have taken A intersection common from it. So what is remaining? B union C. Right? Okay. Let's do the next one. In the Venn diagram, find A union B. Right? In the Venn diagram, find A union B. Okay. So if you see in set A, what are the set? 2, 4. Right? And set B, it is what? 3, 2 and 4. Right? 2 and 4 also lies in set B. Right? 2 and 4 also lies in set B. That is why we will say they are asking us to find A union B. Right? A union B. So A union B will be nothing but 2, 3 and 4, which is nothing but B. Right? Which is nothing but B. Right? And if they suppose ask you what is A intersection B, A intersection B is nothing the common area, which is 2, 4. Right? Which is what? 2, 4. So the answer for this, because they are asking A union B, will be how much? D. Right? It will be how much? D. Alright. I hope this is clear to everyone why it is D. Okay, it is nothing but set B. Then next, the shaded region in the given figure is, right? The shaded region in the given figure is. So if you see this kind of question we have practiced yesterday, this is only A, right? This is only what? Which part? A part. Correct? So what have we done? We have, okay, what are we doing here? We have taken union of B and C, right? B union C will be this area, right? And if I subtract that from the area which is present in A but not in B union C, present in A but not in B union C. So I will say A minus B union C, right? It will be what? A minus B union C, correct? So that is why the answer will be what? D, right? The answer for this will be how much? D. Okay, I hope this is clear to everyone why it is like this. If they are suppose saying A intersection B union C, right? A intersection B union C. So what it will be coming? This is A, right? Let this be A, this be B, this is C. For the first one, what will be the answer? Right? A intersection B union C. What I will do? First I will do B union C and then I have to take intersection. So what this area will be coming? Right, this area will be what? The first part, A, but this is not given in the question. They have given the upper part, so that is why that is not the answer. Then they have given B intersection C union A, right? B intersection C union A. So for that, which area will be coming? B intersection C. B intersection C is this area, right? And union with A. So which area will be coming? This area, right? And this, right? For the second one, this area will be coming, right? And then A intersection B minus C, right? A intersection B minus C. So if I find B minus C, it will be this area, right? Let me do some other color. Okay, so B minus C will be this area, right? But I need to take what? I need to take intersection with A. So which area will be this part, right? This part will be what? A intersection. But what we are supposed to find out? We are supposed to find out this area. So that is why it is what? Option D. But I have explained you all the other options also. Okay. I hope it is clear to everyone. Next. Question 7th. Let A equal to X. X is such that X belongs to real number between -1 to 1. So for this kind of question, what we have to do? We have to draw a number line, right? So we'll draw a number line here, right? We will draw a number line. We'll put all the kind of numbers, right? So I'll put, let's say -2, -1, 0, 1, and 2, right? Now what is the set A? Set A, they are saying it is the numbers between -1 and 1. Right? All the real numbers between -1 and 1. But mind it, -1 and 1 are not included here, right? So I'll say here, right, -1 to 1, all this number. And why I have put white ball? Because -1 and 1 are not included in this. Okay. Now what is set B? For set B, right, set B is what? Less than or equal to 0 or greater than equal to 2, right? So if I want to find out less than or equal to 0, right? So I'll play, since it is equal to, right? I'll place a dark ball here and it will go on the left side, right? And if it is saying greater than or equal to 2, so I'll place again a dark ball here. I'll go on this side, right? I'll go on this side. Now what they are saying, A union B is equal to R minus D. If I find out what is A union B, so for A union B, which sets will be coming, right? A union B, if I see, right, this area completely will be coming in A union B, right? Even this area will also be coming, right? Because this green part comes under B, right? This part also comes under B, and yellow part, this part comes under only A, right? Now what they are saying, it is equal to R minus D, right? This is another set D from which, from all the real numbers, we have to subtract this D, this D area, right? So what will be the set D, right? So the set D will be actually this area, right? Set D will be actually what? This area, and this area will be denoted by what? See, 1 is not included in set A, right? Because at 1 there is a white ball, right? So it means that 1 will be included in this set, right? So there will be a dark ball here at 1, right? And then 2 is included here, so there will be a white ball here. So that is why, right, this is the particular set which we have to remove from all the real numbers, right? So what is this set? We will be starting from 1 but less than 2, right? So 1 less than 2 is which one? B. 1 less than 2 is which one? Option B, right? I hope this is clear to everyone. Next, if A equal to 2, 3, 4, 8, 10 and B equal to 3, 4, 5, 10, 12, C equal to 4, 5, 6, all this is given, and what they are asking us to find, A intersection B union A intersection C, right? So first what I'll do, I'll find out A intersection B here, right? What will be A intersection B? What is common? So 3 is common, right? 4 is common, then 10 is common. So in this, it will be what? 3, 4 and 10, right? Then A intersection C. A intersection C. So in A and C, right, what is common? A and C, 4 is common, right? Then 5 is not there, 6 is not there, 10 is, 8 is also not there. Nothing is common. I think only 4 is common in this, right? Yes. And what we have to do, we have to take the union of these two, right? We have to take the union of these two. So it will be A intersection B union A intersection C will be just 3, 4 and 10, because anyway 4 was already there in here, right? So it will be how much? 3, 4 and 10. So the answer for this is what? Option A, right? The answer for this is what? Option A, correct? Now, this question can also be done in this way, since A intersection and A intersection is common in this two, right? Just like I explained before, I can take A intersection common and I'll get B union C, right? What I will get? A intersection common, I'll get B union C. If I have now B union C, first I need to find out B union C, right? In this way, if I want to do, what I need to find out first? B union C. So B union C will be how much? If I see, it will be 3, 4, 5, 6, 7 is not there, 8 is not there, 9 is not there, 10, then 12 and then 14, right? This is what? B union C. And what is A? If I take an intersection of this with what? With A, right? I'll write A here also. So A is what? 2, 3, 4, 8 and 10, right? 2, 3, 4, 8 what? And 10. So what is common between them? You can see 3 is common, then 4 is common and then 10 is common. So that's why A intersection B union C will be again 3, 4 and 10, right? So the correct answer for this will be option A, right? The correct option for this is what? Option A, alright? I hope this is clear to everyone. Next, let U equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is 1 to 5 and B is 6, 7. Then A intersection B complement. A intersection B complement. Okay. So what I'll do, this question will be best, I'll be doing it best done by what? Venn diagram, but I'll be doing with both methods. Right. So what I can do here is, first I'll make a Venn diagram. Okay. In set A, there is 1, 2 and 5. Right. So in set A, there is 1, 2 and 5. Right. And there is a set B, there is nothing common between A and B. So it is what? 6 and 7. 6 and 7. Right. Now apart from these 5 numbers, everything will be coming in the universal set. So universal set, it will be how much? 3, I guess 4, 5 is not there, 6 is not there, 7 is not there, 8, right, then 9 and then also 10, right. All this number will be coming in what? Universal set. Now what they are saying, A intersection B dash, right. So A intersection B dash, right. If I find out B dash, right, what will be B dash here? B dash will be, this is B, right, this is A. So B dash will be everything but B, right, this part. Right, so if I take intersection with A, this 3 numbers will be coming, right. So can I say A intersection B dash will be nothing but 1, 2 and 5, right, it will be nothing but 1, 2 and 5, right. So this is nothing but A itself, right. What will be this? This will be nothing but A itself, right. This is we have done through Venn diagram. Now I'll be doing the same thing without the Venn diagram, right. So how will I do? They have given us B, right, they have given us U, so I can find out B dash. It will be how much? 1, 2, 3, 4, 5, 8, 9 and 10, right. And they have also given us A. A is how much? 1, 2 and 5. So what will be A intersection B dash, right, A intersection B dash? It will be again 1, 2 and 5. You can see here 1 is common, 2 is common and 5 is common, right. So it is 1, 2 and 5. Correct? Alright, I hope this is clear to everyone. So correct answer for this is what? Option A. Sorry, option A. Option is B, the answer is A. Okay. Next. Okay, 10th question. In 10th, what they are saying, if A is equal to 4n plus 1, n is less than equal to 5, and B is 3n, n is less than equal to 8, then A minus B is equal to what? Okay, so what we'll do, we'll first find out A and B, right? How will I find out? They have given us n is a natural number and n is less than equal to 5, right? So what I'll do, I'll just plug in this value here, right? So if I put n equal to 1, I'll get 5. I'll put 2, I'll get 9. Then I'll get 13, right? Then I will be getting 17, and at last I will be getting what? 21, right? What have I done here? I have put the value of n from n equal to 1, 2, 3, 4 and 5. Why 5 till 5? Because they have given n is less than or equal to 5. That is what they have given. Correct. Now for set B, right, n is less than or equal to 8 and belongs to natural numbers. So it will be what? I'll put n equal to 1, so I'll get 3, right? Then I'll get 6, then I'll get 9, then I'll get 12, then 15, then 18, then 21 and at last 24, right? At last what we will get? 24. Why 24? Because they have given n is what? 8. Okay. Now what they are saying, A minus B, right? A minus B. So if I want to find out A minus B, right? A minus B. Elements are present only in A, right? Elements are present only in A. So see this common 9 is there, right? So this will not be coming. Then 13 is not there. I think 21 is there, right? So this common elements will not be coming. So for A minus B it will be how much? 5, 13 and then 17. and then 17, right? 5, 13 and what? 17, correct? And now we need to find out A minus B, right? A minus B. So what I'll be getting? We don't need 5, 13 and from A I'll remove 5, 13 and 17. So what I'll get? I'll get 9 and 21. Right? I'll get 9 and 21. So the answer for this will be what? Option A. Right? The answer for this will be what? Option A. Okay. I hope I'm clear from here. Right? I'll also do this thing same from Venn diagram. So from Venn diagram, if I do it, right? So this is, let's say A, right? This was B, right? A and B. So see, A minus B will is what? A minus B will be this thing, right? And from A, if I remove this part, right? From A, if I remove this part, so what I'll be getting? I'll be getting this part, right? I'll be getting what? This part. So this part is how much? This part is nothing but A intersection B, right? This part is nothing but A intersection B. So can I say from here that A minus B is equal to A intersection, is equal to what? A intersection B. Alright, I hope I am clear with this. Okay, next. Which of the following Venn diagram best represents the set of females, mothers and doctors, right? Females, mothers and doctors, right? Okay, so see, every female, right? Every female can be a mother also and can be a doctor also, right? Okay, so this is not a possibility, right? Why it is not a possibility? Why it is not a possibility? Because if I say that this is a doctor and this is a female and this is a mother, right? Then it is not a possibility because a doctor can be a female also. So this is not wrong. This is wrong, right? What in this case, right? Why this is also incorrect? Why this is also incorrect? Because if I say, let's say this is female, this is mother, and this is doctors, right? So which area is this? Mothers who are not female, right? Mothers who are not female and not doctors. It's not possible. A mother has to be a female, right? That's why it is also not correct. Option B is incorrect, right? Again, this is also not possible because female, mothers and doctors. Female has to be a mother has to be a female, right? That's why it is not a right answer. Okay. Now, here if you see this is a female, right? Then this is a mother and this set will be a what? Doctor, right? So a mother can be a doctor, a mother will be a female also, and this area represent what? A female who is not a mother but a doctor, right? So this particular Venn diagram is representing the right way, right? So the answer for this is what? Option D, right? The correct answer for this is what? Option D. Okay, I hope I am clear for this one, right? Why it is like this. Okay, let's go to the next one. In a school, there are 3 types of games to be played. Some of the students play 2 types of games, but none play all the 3 games, right? None play all the 3 games. Which Venn diagram can justify the statement, right? There are what they are saying, there are 3 types of games to be played. Some of the students played 2 types of game, but none play all the 3 games, right? None play all the 3 games. So if you see in this, all the 3, there has to be no common area. There has to be no common area for what? P, Q and R, right? No common area for P, Q and R. But if you see, right, this area is common between P, Q and R, right? So I guess the answer for this will be what? None of this, right? The answer for this will be what? None of this. Okay, that is why, because they are saying clearly none play all the 3 games. So this particular area, right, in both the diagram, right, is coming is actually showing that they are playing all the 3 games, right? I hope I am clear for this. Next, if sets A and B have 3 and 6 elements respectively, then the sum of minimum and maximum number of elements in A union B, right? Sum of minimum and maximum number of elements in A union B, right? Okay, this is the last question. So see here, for minimum, right? For minimum, the bigger set, the bigger is, oops, the bigger one is what? The bigger one is here B. This is B and this is what? A. Correct? This is B and this is A. So for minimum number of elements, right, in A union B, can I say that B will completely take A? Right? A will be completely inside what? B. Right? So this is 3 and this is 6. Correct? So the sum of, so for minimum value of what is A union B? Minimum value of A union B is how much? 3. Right? Minimum value of A union B is how much? 3. And for maximum value they will be completely outside. So this is B, right, and this is A. So I can say maximum value of A union B is how much? 9. Right? Maximum value of A union B is how much? 9. So if I add them, right? So they are saying A union B, right? So A union B, this will be how much? 6. This is not 3, this is 6, right? So if I add them, sum will be equal to what? 6 plus 9, which is how much? 15, right? So the correct answer for this is what? Option C. Right? The correct option for this is how much? Option C. Okay. I hope I am clear with this one. Right? This question is clear to everyone. This is option C. Okay. So with this, we have completed all the discussion of the questions. Now we will be doing today's theory, which is operations on set. Right? Operations on set. So we'll be doing them one by one. I'll be explaining you how to do operations on set. Okay. Let's go to the note slides. Okay, right? So we'll write down, I think, operations on set. Just a minute. Now I think operation we have done, some fundamental laws, right? The heading is what? Some fundamental laws of algebra of sets, right? Some fundamental laws of algebra of sets. Okay, right? Okay, first is what? First is what? Idempotent law, right? Idempotent. The name you don't have to actually remember, right? Idempotent law, right? For any set A, right? For any set A, what we can say? A union A, right? For any set A union A, right, will be equal to A, right? A union A will be equal to A, and A intersection A will also be equal to what? A. It will also be equal to what? A. This is known as idempotent law. Right. Then second, identity law. Right. Second is what? Identity law. So what is that? It is saying that A intersection phi, right? A intersection phi will be equal to what? Phi, right? And A intersection universal set will be equal to what? A, right? A intersection universal set will be equal to what? A. And also we can say from here that A union phi will be equal to what? A, right? A union phi will be equal to what? A. Understood? Okay. Okay, I hope this is clear to everyone. The identity law and idempotent law. Then next is what? Commutative law. Next is what? Commutative law. Commutative law. Right? Commutative law. Now what is commutative law? A union B, right, will be equal to what? B union A. Right? This is the first one. Okay, I'll write it in white color. A union B will be equal to what? B union A. That is, if you reverse the particular set also, right, this union will not change, right? And second, A intersection B will be equal to what? B intersection A, right? A intersection B will be equal to what? B intersection A. So we can say that union and intersection are commutative. Right? So this is the third law, commutative law, right? Then next, fourth, right? Fourth is what? Associative law, right? Fourth is associative law. And what this is saying? A union B intersection C will be equal to B intersection C union A, right? The associative law. And second, okay. Second is what? A intersection B intersection C is equal to A intersection B intersection C, right? And this one will be for union. So A union B union C will be equal to A union B union C, right? So this is what about associative law, right? You can, if all of them are having union, then you can transfer the union, and if all of them are having intersection, you can transfer the intersection, right? The values will not change. Then next, right? Distributive law. Then next is what? Distributive law. Distributive law. What is distributive law? First, A union B intersection C, right? A union B intersection C will be equal to A union B intersection A union C, right? What I have done here, actually, if you see here, what I have done, I have multiplied A union with B and then A union with C, and this sign is coming here, right? This sign is actually coming here. Understood? By same logic, I can also say that A intersection B union C, right? A intersection B union C will be equal to A intersection B union A intersection C, right? A intersection B union A intersection C. Understood? So we can say that we can multiply this. We have already proven through Venn diagram in the previous questions that this A intersection can be transferred, right? So this will multiply with this, and then this will multiply with this, and this sign will be coming in here, right? Okay, so this is about distributive law. Okay, next. Now the last one is very important, right? De Morgan's law. Okay, last one is what? De Morgan's law. Right? De Morgan's law. Now, what is De Morgan's law? I'll tell you. This we have discussed yesterday also. That what is De Morgan's law? That A union B complement, right? First one, A union B complement will be equal to what? A complement intersection B complement, right? A intersection B complement, and second, A intersection B complement will be equal to A complement union B complement, right? This I can show you from Venn diagram also. It's a very important law. This you are supposed to remember, right? Through Venn diagram, if you see here, right? Let's say this is A and this is B, right? This is A and this is B. So if I do A union B, right? A union B, I'll get this part, right? And if I take a complement of this, I will get everything but this area, right? So basically, I will get what? I will get. This is A, this is B, so I'll get this area, right? And this area we can also get by actually doing A complement intersection B complement, right? A complement, because A complement will be what? Everything but A. So everything but A will be this, and this area will be what? Everything but B. So if I take intersection, I will be getting this particular area, right? And same logic for this part, that if I have, let's say this is A, this is B, right? Let's say this is A and this is B. And if I find out A intersection B, what is A intersection B? A intersection B is this, right? And if I take complement of this, it will be this area, right? Everything but this area, and this thing can also be written as what? A complement union B complement, right? Is written as what? A complement union B complement. Alright, I hope this is clear to everyone. What is De Morgan's law, right? Okay. Then next, there are some important results, okay, for this. So we'll see some important results. Before that also there is one more thing we'll do, right? So first we'll do important results. So important results, right? What are the important results? Let's understand this. First, right? First is if A is a subset of B, right? If A is a subset of B, right? Then A union B will be equal to B, right? And A intersection B will be equal to what? A, right? A intersection B will be equal to what? A. It's very easy to understand here. How? See, they are saying if A is a subset of B, so I can say, let's say this is A, right? And this is B, right? This is A and this is B. So if I take union, A union B, right? So if I take union, what will be the union part? This will be the union, right? And if I take intersection will be what? This part will be the intersection, right? So this is nothing but A and this is nothing but B, right? So A union B is equal to B and A intersection B is also equal to A. Okay, I hope I'm clear with this one. First important result. This is very important, so you will please remember this, right? Next, second is what? A minus B, right, is equal to A minus A intersection B, right? A minus A intersection B, or we can say that it is equal to A union B minus B, right? A union B minus B. So this also let's understand through Venn diagram. If I see, this is A, this is B. So what is A minus B? A minus B is those elements which are present in A but not in B, right? present in A but not in B. So which elements will be coming? This elements, right? And to get this, what we have to do? We have to subtract this area, the common area, right? We have to subtract this area, which is the common area, from A. This is one way of doing that. What we are doing, A minus A intersection B. This area, pink area, if I remove from A, I will be getting the yellow area, right? I will be getting the yellow area. And then next part, second way of doing is what? We know A union B is this whole thing, right? A union B is this entire thing, right? Yellow plus pink. But if I remove the pink part, which is what? B, again I will get what? A minus B. So that is why we can say that this is equal to this 2. Understood? This is also again a very important result. So you have to remember this, right? A minus B is equal to A minus A intersection B, or it is equal to A union B minus B. Okay? Next. Third is A minus B union A intersection B will be equal to A, right? A minus B union A intersection B is equal to what? A. How? Let's see. So this is A, this is B, right? What is A minus B? A minus B is this area, right? And what is A intersection B? A intersection B is this area, right? A intersection B is this area. And if I take a union of this and this both, right? If I take a union of this and this both, what I'll be getting? I'll be getting what? A. If I combine this A minus B union A intersection B, then I'll be getting what? A. Okay. This is actually two parts. A is divided into two parts. One is A minus B. This is what? A minus B. And this is what? A intersection B. And if I take a union of this, I will automatically get what? A. I'll get what? A. Okay. I hope I am clear with this one. Right? Okay. Next. This is the third law. Right? Then the fourth one. A minus B union B minus A, right? Union, right? Union A intersection B is equal to nothing but A union B, right? Is equal to nothing but A union B. Now let's understand this part. Again, let's say this is A, this is B, right? Now, what is this area? Right, this is A, right? This is A minus B, right? This is A minus B. Then what is this area? This is A intersection B, right? This is what? A intersection B. And at last, what will be this area? This is nothing but B minus A, right? This is nothing but B minus A. So now if I take union of all the three, right? If I take union of all the three, all this yellow, pink and green area, what will I get? I will get A union B, right? I will get what? A union B. Okay, I hope it is clear to everyone, right? That how we are getting this important results. Next. This is fourth one. Fifth is A minus B union B minus A. Union B minus A is nothing but A union B minus A intersection B. Right? It is equal to what? A union B minus A intersection B. Now how we are getting? Let's understand this also by Venn diagram. The best way to understand anything of set is through Venn diagram, right? So let's say this is A, this is what? B, right? What is A minus B? A minus B is this, right? This is what? A minus B. And what is B minus A? Element which are present in B but not in A. This will be this area, right? This is what? B minus A, correct? Now, in this, if you can see here, that this particular area is not coming, right? If I remove this area from the whole union of it, right? So what I will be getting? A union B minus A intersection B, right? What I will be getting? A union B minus A intersection B. So definitely this will be the right equality, right? So we can say that A minus B union B minus A is equal to A union B minus A intersection B, right? Okay, let's go to the next thing. Sixth, A is a subset of A union B and B is also a subset of A union B and A intersection B is a subset of A and A intersection B is a subset of B, right? So A is a subset of A union B, that is correct, right? So if I want to draw, this is A, right? This is B, right? This is A and this is B. So we can say that if I want to find out A union B, what will be A union B? This whole thing, right? This is what? A union B, and from this A union B, right? A is just a part of it, right? That's why this is correct, right? Now next, B is a subset of A union B. This is also correct. B is also a part of A union B, right? Next, A intersection B. A intersection B is a subset of A. This is also correct. A intersection B is what? Subset of A. It's a part of A. This is also correct, right? And then last, A intersection B is a subset of what? B. It is also correct. This particular part is the part of what? B, right? A intersection B is a subset of what? B. So I guess you understood all of this subset property. Next. Next, seventh. A minus B is equal to A intersection B complement, right? A minus B is equal to what? A intersection B complement. So let's see from Venn diagram. This is A, right? This is B, right? Now what is A minus B? A minus B, we all know that it is this area, right? This is what? A minus B. Now if I find B complement is what? B complement is everything but B, right? This is what? B complement. And for B complement, what they are saying, that A intersection B complement, right? A intersection B complement. So if I take the intersection of A, right, with this pink area, what I will be getting? I will be getting this yellow area only, right? I will be getting this yellow area only, right? So this equality also holds true. Understood? A minus B can be written as what? A intersection B complement. Okay. Then next, one more, last I guess, yes. Eighth, A minus B union B, right? A minus B union B is what? A union B, right? A minus B union B is what? A union B. Now should understand this one. This is A, this is B, right? Now what is A minus B? A minus B is this area, right? And what is B? B, so anyway we all know it is this area, right? A is this, A minus B is this, and B is this. So if I take A minus B union B, what I am going to get? This completely A union B, right? So this equality what they have written is correct, right? That A minus B union B is equal to what? A union B. Okay. Next. Now there are a few important notes, right? What are the notes? And then we'll do one or two questions on this, right? So what are the nodes? Node. Node is first A minus B union C, right? A minus B union C. What I can do here? I can do distributive. So A minus B union A minus C, right? Then second, A minus B intersection C will be same as, okay, so A minus B intersection C is what? A minus B, right? Union A minus C, okay. Here there will be intersection, okay. Here will be what? Intersection, alright. Let's understand this through Venn diagram. So let's say this is A, this is B, and this is C, right? So what is B union C? B union C will be this area, right? And if I remove A from it, right? If I remove A from it, right? So what I will be getting? Elements which are from A. If I remove this area, right? What I will be getting? I will be getting this thing. Right, I'll be getting this thing. Now let's see from here whether I am getting the same thing or not. So what is A minus B? A minus will be this area, right? And if I take intersection with A minus C, A minus C will be what? This area, right? So the common area for that will be what? The common area for that will be same as this pink area what we have got. Understood? So I hope this note is clear to everyone that A minus B union C, right, whenever we multiply with minus or we distribute minus, this union get converted into what? Intersection, right? And same here, that whenever this minus we are distributing with intersection, it is converted into what? Union. Okay, I hope this is clear to everyone, right? Next is second note. What is the second note? Second note is saying A intersection phi is equal to phi. This we already saw, and A union universal set will be equal to what? Universal set, right? Will be equal to what? Universal set. Okay, because if I take a union of A with universal set, I will be getting the universal set because A is subset of universal set, correct? And here A intersection phi, there can be nothing common between a void set and A, right? A be any set. There can be nothing common between A and the void set. That's why it is also equal to what? Phi. Right? Okay. So this marks the end of the theory. Now we'll be doing few questions based on this, right? And then we'll be giving you homework. So let's write down one question. Let A and B be two sets, right? If A intersection X is equal to B intersection X is equal to phi, right? And A union X is equal to B union X, right? For some set X, for some set X, right? Then prove that A is equal to B, right? Then prove that A is equal to B, right? So how will I prove this? How will I prove this? They are saying that A union X. Okay. Now what I'll do, since A union X is equal to, they have given B union X, right? From here, A union X is equal to what? B union X. What I will do, I will take intersection A union X, right? A intersection A union X, right? Will be equal to what? A intersection B union X, right? A intersection A union X will be equal to what? A intersection B union X, right? Now If I distribute this, right, what will I get? I will get A intersection B. Right, this will be what? A intersection B union A intersection X. Sorry, A intersection X. A intersection X. But what is A intersection X here? They have given it to be what? Phi. So I'll be getting on this side, I'll be getting A intersection B union phi. Right, union phi. And on this side, what I will be getting? A intersection A, right, union A union X. Right, A intersection, not union, it will be intersection. Right, by distributive property. Again, this is what? This is nothing but null set. So I can say it is A intersection A, right? A intersection A union phi, right? And what is A intersection A? It is A. A union phi will also be what? A. Right? A union phi is what? A. Just now we saw. And from here, if I take union with this, I'll be getting what? A intersection B. Right? And if A is equal to A intersection B, A is equal to A intersection B, right? So I can say that B and A are what? Equal. Right? B and A are what? Equal. Because the common area between B and A is equal to the A itself. So that is only possible when B is equivalent to what? A. Okay. So I hope this is clear to everyone. We have proved that A is equal to B. Right? Okay. Now next, using properties, right? We need to show that A union B, right? Intersection A intersection B dash, right? A intersection B dash is equal to A, right? Is equal to A. We need to show it using what? Properties, right? A union B intersection A intersection B, right? So what I will do, right? What I will do here, I will write, see, we know what is A union B. This is A, right? This is B, right? So if I do A union B is nothing but this whole area, right? And if I want to take an intersection with A intersection B dash, this is what? This is nothing but just A, right? Just A. And if I again take intersection of this with this, what I am going to get? I am going to get what? A. Right? I am going to get what? A. This is very easy to understand through Venn diagram rather than understanding through what? Understanding through property, right? So that is why I guess Venn diagram is right for this. Okay. Then next, we need to state true or false, right? A union A dash, right? And second, universal set intersection A is equal to A. A union A dash is equal to what? A. Right? A union A dash is equal to A, and universal set intersection A is equal to A, whether it is true or not. Right? So the first one, A union A dash, right? So if I say this is A, right? Let's say this is A, this is a universal set. So A union A dash, this is A dash, right? A union A dash actually will be equal to what? U, right? This will not be equal. So that's why it will be what? False, right? It will be equal to what? U, and it will not be equal. So it will be what? False. And universal set intersection A, right? If I take, this is a universal set, and if I take an intersection with A, I will get what? Automatically I will get what? A only. So that is why this is what? Correct. Understood? This is what? Correct. The next is a very important question. Okay. So next question we'll understand, and then we'll give you homework, right? What is that? Each set each set X contains 5 elements and each set Y contains 2 elements. Contains 2 elements, right? And what they are saying, union of R equal to 1 to 20 Xi will be equal to S, and union of R equal to 1 to Yi, right? R. This is also R, right? If each element of X, right, each element of X belongs to exactly 10 of XRs, right? Exactly 10 of XRs, right? Then and to exactly 4 of YR, right? Exactly 4 of YRs, then N equal to what, right? Then N is equal to what? So in this case, what they have given that let each set X contain 5 elements, right? And how many X are there? 20, right? So total number of elements in set S will be how much? And S will be how much? 5 into 20, right? 5 into 20, correct? And also each set Y contains 2 elements, right? Each set Y contain how much? 2 elements. So I can say total number of elements in S will be how much? Through this way, if I go, it will be what? 2n, right? And if each element of X belongs to exactly 10 of XRs, right? So how many XRs will be there? How many elements will be there? So it will be 20 into 5 divided by what? 10, right? This will be number of elements, right? And it will be equal to what they have given. It is exactly equal to 4 of YRs, exactly equal to 4 of YR. So what I'll do from YR point of view, what I'll do, I'll write 2n by 4, right? So now if I equate this, I'll get 2, this will be cancelled to 10, 10 and 10 cancel. So n will be equal to what? 4 into 5, which is 20, right? N will be equal to what? 20, right? So we can say that the number of elements, right, in this set again will be what? 20 only, the same as XR. Okay, this question is very important because this question is there in your homework also. In 2 of the worksheet, this question is there, right? So I guess it is clear now, right? Now for tomorrow, the homework is, tomorrow means like Monday, right? Today is Friday. So for Monday, the homework is worksheet number 17, right? Worksheet number 17. Yes, it's worksheet number 17. Right? Worksheet number 17, page number it is 79. Page 79 and 80, right? Page number 79 and 80, all 11 questions. Right? So on Monday I'll be discussing that, and I'll be also doing worksheet number 18 in class, right? Worksheet number 18, some of the question I'll do in class, and then some of them will be keeping it for Tuesday, because Tuesday is the last lecture, right? So Tuesday I'll be completing the whole questions from worksheet number 18 and 19. All right. So see you on Monday. Okay. I hope this question will be done. Thank you.